Right, here is question number 7. A ship is docked at the wharf. The path followed by the rope from the bollard can be approximated by a parabola, and it has an equation y equals 0.2x squared minus 1.6x plus 4.8. So I've sketched the drawing right there. And the first part of the question asks to calculate the height of the rope above the water at the points where it is attached to the bollard and the capstan. So if we make the axes x and y as shown, so where it is attached to the bollard would be at x equals 0. So if we substitute 0 into that, all we're left with is 4.8. So this point here is 4.8. If we substitute 7 into this, because we're told it's 7 meters apart, so we can show that that's 7 meters. So F7 now is equal to 0.2 times 7 squared minus 1.6 times 4.8, which when you work all of that out is equal to 3.4. So if we change colour a little bit, we can see that this line across here is equal to 3. Well, let's carry on and differentiate this function, which is what it asks us to do. So if I do that, I get 0.4x minus 1.6. And the next part of the question asks us to find the lowest point of the rope, which would be there. So we do that by setting that equation equal to 0. So 0.4x minus 1.6 is equal to 0. Adding 1.6 to both sides, that's equal to 1.6. And therefore x is equal to 4. We now need to substitute 4 into the original equation to calculate the height that the rope is above the water. And so if we do that, F4 is equal to 0.2 times 4 squared minus 1.6 times 4 plus 4.8, which is equal to 1.6. No, it's not. Yes, it is 1.6, and so there it is here. If we put that in blue on the diagram, you can see that the height is 1.6 and the x value is 4, so we've got a coordinate of 4 and 1.6, which gives us the lowest point on the curve. Now we come to D, and DI says how high would the water level have to rise for the capstan to be level horizontally with the bollard? Well, that's this amount right there. So here is the capstan, here is the bollard, and so shown in blue is the difference between those two. So that's just equal to 4.8 minus 3.4, which is equal to 1.4. And D, 2I, says when the water level has risen by the distance in part I, the height of the rope of the water can be modelled by the parabola y equals ax minus b all squared. So I've shown on a new set of axes a water level rise of 1.4, which raises the x-axis by 1.4 or lowers everything else by 1.4. So now the bollard and the capstan are at 3.4 meters above water level. It says the rope is touching the water, so if it is a parabola, because of symmetry, it would be touching the water halfway between 0 and 7, which is at 3.5. To solve the rest of the equation, y equals ax minus b all squared, and to find values for a and b, we choose two coordinates on the line, and convenient ones are ones that include 0 somewhere. So I've circled both of those, 0 and 3.4, and 3.5 and 0. So having substituted in 0 and 3.4, then AX disappears. Y is equal to 3.4, and negative b all squared is b squared, so b squared is equal to 3.4, and b is equal to the square root of 3.4, which is equal to 1.843. And carrying on, I've written out the new equation, replacing b with the square root of 3.4, and now use the other coordinate where y is equal to 0 and x is equal to 3.5, so we end up with 3.5x minus the square root of 3.4 all squared. Taking the square root of both sides, which effectively removes that, I still get 0 is equal to 3.5x minus the square root of 3.4. Adding the square root of 3.4 to both sides, 3.5x is equal to 1.843, dividing both sides by 3.5, and that should be a, not x. So apologies there, fix that up. And when we do that division, a is equal to 0.5268. So there they are there. B is 1.843 and A is equal to 0.5268.